welcome back to McClutchy Maths. My name is Natalie McClutchy and today we're going to be continuing our series on time series. This is a series where we're going to look today at how to fit a least squares regression line to time series data. Now, I'm going to be assuming that you've watched my bivariate data video series. If you haven't, it might be a good idea to go back and have a quick recap on what a least squares regression line is, what the formula is for that, how we derive that particular equation, because that's pre-assumed knowledge in this particular video. In this video, I am aiming at students in Queensland, Western Australia, in Tasmania, in Year 12 and Year 11 if you're in Tasmania. So firstly, in this video, I'm going to do a quick recap on least squared regressions lines. It's not going to be in depth, but it'll do a quick recap. And then I'm going to show you how to develop that equation manually using algebra and then also using a calculator with some worked examples. So firstly, I'll recap on LSR lines. You would recall from my bivariate data series, just giving that little plug there, that a least squared regression line can be fitted to data on a scatter plot. Now, we're not looking at scatter plots in this series, we're looking at time series, but the principle of fitting a least squared regression line to data where you've got something on the x-axis and something different on the y-axis, and that's basically what we have with the time series. But as you would recall, time series are different to scatter plots. But we can fit that to the time series in order to be able to make some predictions about the future trends. And that's a form of extrapolation because obviously the future hasn't happened yet. Okay, and you would also recall from our previous videos that the equation of a least squared regression line is y equals a plus bx. If you are joining us from South Australia, they do use a different formula there for the least squared regression lines. They go with y equals ax plus b. It's not a big deal what your variables are, but it's important to note that if you're using a Texas Instruments calculator, it follows the South Australia equation, not the equation that we use here in Queensland, Western Australia and Tasmania. Now that's a little diversion. So it's important to remember that if you're joining us with a Texas Instruments calculator, your value for A and B are reversed because it's programmed differently. If you're using a Casio calculator, which I'm going to be using in this video, you're all sweet because it uses A and B in the same way that I'm going to be doing in this video. You'd also recall, and this is on your formula sheet if you're joining us from Queensland, that B is equal to Pearson's correlation coefficient R multiplied by the standard deviation of Y divided by the standard deviation of X. And in a time series, the standard deviation of X is the standard deviation of time periods. And you would also recall that A is equal to the mean of Y minus B multiplied by the mean of X. And in a time series, the mean of X is the average time period as well. And that kind of doesn't make a lot of sense because if you're thinking about a time series, you've got month 1, month 2, month 3, month 4, month 5. You're thinking, why would I take an average of those? And why would I find the standard deviation of those? Because they're always going to be equally spaced out. So that it doesn't make a lot of sense to do that. However, in order to create a least squared regression line and use that line to extrapolate and make predictions, then we use that information about our means for that x-axis. Doesn't make a lot of logical sense to calculate the mean of 6 months. Of course, it's going to be the number in the middle, but that's just what we do. You'd also recall those dangers of extrapolation. Not going to go into that in a great deal of detail here, but just to say that if you haven't experienced something yet, it's dangerous to make predictions and rely on them heavily. Okay, so let's get right into our first worked example. We're going to do this one manually using algebra. So the summary statistics below have been developed for the average price of petrol over a 12-week period. I actually pulled these petrol prices out and calculated this information myself. We've got the mean of X is 6.5, the mean of Y 117.28, the standard deviations and Pearson's correlation coefficient. We've got everything we need there to develop A and B and therefore the equation of the least squared regression line. When we've done that, we've got that equation, we're going to then use that to predict petrol price in week 15 and then evaluate the reliability of that prediction. I think it'd be a great idea for you to pause the video right here and see if you can do this all by yourself, and then you can check in with me afterwards to see if you got everything right, or if you're just not sure what you're doing, then just continue playing on. Okay, so firstly, you're going to find B. You need to write the formula. Now, if you're in Queensland, that's on a formula sheet for you. Sweet. So you're going to take R, which is negative 0.6866, and substitute that into the formula. Multiply that by the two standard deviations, one on top of the other, and you're going to evaluate that in small steps. So I would recommend simplifying that fraction on the right-hand side first, keeping that number on your calculator. Don't round it off yet. Don't round it till the very end. And then you're going to work out that b is equal to negative 1.0335. You're going to need to write that down somewhere because you're going to need that to create your equation in a moment. The next step is you're going to find a. You need to write the formula first. It's those means, take away the other means. And you're going to substitute into the formula. So you've now found b, so you can use that in this particular formula. That's why it's important to get b right at the very beginning, because you rely on it to create a. We're going to evaluate that in some small steps as well. And then we notice that that minus becomes a positive. That's really important. That's probably one of the most common mistakes that I do see when I'm marking students' work, is their use of algebra, and they forget that negative becomes positive. So that's why it's important to take your time and take some small steps here. And we're going to simplify that to a is equal to 123.9978. Now we're going to substitute that information into that least squared regression equation. So that y equals a plus bx becomes y equals 123.9978, take away 1.0335x. Okay, now we need to find the petrol price in week 15. So the weeks always go on the x-axis for time series, that's time on the bottom. So x is going to be equal to 15. We can simply substitute that into our equation and work out the value for y, which is that predicted petrol price. So if we substitute that in, we work out that the future price is going to be 108.5 cents per litre. It's always a good idea to have a couple of decimal places, but I would suggest too that in a case like this, you're not going to go and see that at a petrol pump with 3 decimal places. It'd probably be better to write a statement with that and round it off to 108.5 cents per litre. And always make sure you remember your units at the end. That's one of the other common mistakes I see, is students forgetting the units, and then you lose marks that you're just throwing away for no good reason. Okay, now we need to evaluate how predictable our petrol price is. Can we rely on that for week 15? Well, firstly, the prediction's extrapolation, and therefore it's measuring events beyond the data which has been observed, and that can be unreliable. And let's face it, the price of petrol is reliant on so many different factors around the world. It's really hard to make a useful prediction. You can still make a prediction, but you're not going to get it spot on. And that's one of the things about it. But I think in a question like this, if you're in an exam, the most important thing is that you are using the word extrapolation. That's identifying what you're actually doing with that equation. You're actually moving into the realm of what hasn't been discovered yet. It's also really important then that you understand that that's dangerous because you've got this circumstances. There's so many different external factors that can be taking place with your least squared regression line. And further, the correlation that we measured, or that was provided to us, is negative 69%. Which is only moderate correlation, and that implies there's going to be some limitations for using our least squared regression line to make predictions. Obviously, if we had perfect correlation, we could assume that this is following a pattern that has no elements of randomness in it. There's no other external facts that are taking any play on the data. Okay, we're on to our second example. This is one where we're going to use our calculator, so hopefully you've got your Casio out and you can work along with me. We are looking at the average price of gold in US dollars over a 6-month period, and we're going to find that equation of the least squared regression line. So firstly, you need to write down your formula, y equals a plus bx, and that's where we're going to skip out now to the calculator, which I've got on my screen, and we are going to enter the data into the calculator. So at the moment, you'll notice we've got January, February, March, April, May, June. Well, they aren't words that are on your calculator. So we're actually going to replace those with numbers. The first month is January, so it's going to be number 1. February will be number 2, March will be number 3, and so on. Okay, so if you've got quarters, or if you've got seasons, or if you've got months or weeks, you're just going to use simple numbers 1, 2, 3, 4, 5, 6. So firstly, what I'm going to do is set my calculator up ready for statistics mode. On that mode button, I'm going to press number 2, and then you'll notice here, it shows me my equation, what that's going to be, y equals a plus bx. And that's always a good idea so that you can write that down in your formula sheet. But also, if you're not sure what your calculator does, if you're not using a Casio, you can check to see what actual procedure it's going to be using. And that way you know when it gives you a variable for a, where to put it in the equation correctly. Okay, so we're going to choose number 2 there. And now I'm simply going to enter the information from this table. So remember I said that the x values are our time series, our time value as our explanatory variable on the x-axis. So we're going to put in there number 1, 2, 3, 4, 5, and 6. That's fairly quick. And then over here we're going to put our price of gold. So we'll type that into the calculator here. I would suggest you're doing that along with me so that you're getting familiar with how to use your calculator effectively. Okay, so now we've got our 6 months of data in there. It's always a good idea just to quickly check that you've done your data entry correctly. Okay, and now we can press the all clear button. Now we're going to press the shift button and come down to the number 1 button where we've got stat above the number 1. And we're going to choose the button number 5 where it has reg. And you'll notice here it's going to provide us with A and B. Excellent. So we're going to start with number 1. And that's equal to, A is equal to 1,652.66 repeater. A good idea to write that down somewhere because you're going to need that to develop your equation in a moment. Okay, so then we're going to press that again and we're going to come up with number 2, and that's going to be 54 is our value for B. So let's now put that all into an equation together. Come back over here. And using our calculator, we've got that information. So therefore, our equation for our line is y equals 1,652.67. I've rounded that off, plus 54x. Well, we have run out of time today. Hopefully you'll be able to use your calculator to find those equations in the future. In our coming up videos, we're going to find out how to smooth time series data, so lots of information there, how to calculate seasonal indices, how to deseasonalize data, and then I'm going to pull some complex questions out of past exams and show you the solutions for those. So if you want to know when these videos are ready, you've got to hit that notifications button and like and subscribe to the channel so you'll know when I've got new videos out ready for you to watch. Alternatively, you can follow me on Facebook on McClutchy Maths, and that's a great way too because I always announce on Facebook when I have a new video available. Well, have a wonderful day and thank you so much for joining me here.